Hi guys, welcome to lesson 8.4 on multiplying and dividing rational expressions. Again, the idea that these are rational expressions, in that they're rational expressions, that means that basically they're some sort of an expression involving a fraction. Now this lesson is going to go really well if you have a very firm grasp of factoring. Okay? If you're not very good at factoring, you want to review lessons 4.3 and 4.4 back from Algebra 2A. And you can actually get to those videos if you just do a YouTube search for my video content, or if you look at my channel on the YouTube site. Another way you can do it is you can access that as a guest via my Moodle site under Algebra 2A. So again, some things to kind of review in that, and we'll spend some time reviewing that content before we get into this lesson. Hopefully we've already done that at this time. So just a couple things in terms of some vocabulary. It says the simplified form of a rational expression is a rational expression in which its numerator and denominator have no common factors. Those common factors, anything other than plus or minus 1. Now, in its simplest form, if you think about any sort of a rational expression, like for example, AC over BC, basically the C's would cancel out and you get A over B. And that seems pretty straightforward, but it's when we start getting into these things where these are now expressions where we have some sort of a binomial or a quadratic or some sort of a polynomial function where we're trying to simplify these. So let's take a look at some examples here. Let's look at example number 1. In example 1, it says simplify a rational expression. So we need to simplify this, and so we want to factor x squared plus 7x plus 10, and this happens to factor into x and x, and two numbers that multiply to 10 that add to 7 are 5 and 2, and so this is x plus 5 and x plus 2. Because the denominator is the difference of squares pattern, this is x plus 2 and x minus 2. Now you'll notice that both the top and the bottom both have an x plus 2. So we're going to go ahead and divide that out. We're going to end up with x plus 5 over x minus 2. All right, so we get rid of that common factor of x plus 2 in both the top and the bottom. And then we just go ahead and rewrite your fraction. Okay? Multiplying rational expressions is very much the same. Keep in mind that when you multiply fractions, we multiply the tops and we multiply the bottoms, and then we simplify. All right. So it says let A, B, C, and D be non-zero real numbers or variable expressions. The rule for multiplying rational expressions is the same as the rule for multiplying numerical fractions. Multiply first the numerators and multiply the denominators. And then write your new fraction, and here's the key, in simplified form. All right, so this would be simply A times C over B times D, and then if that has any common factors, we would go ahead and simplify. All right, so let's take a look at how that kind of applies to what we're working on in this section. Let's look at multiplying some rational expressions on top of the next page. All right. Now, before we multiply these, it's not a bad idea to factor them first. All right. And so if I'm going to write this now as we're going to factor out the greatest common monomial factor of 2x squared and 4x, which happens to be 2x, that leaves me with an x plus 2. And so I want to rewrite the first fraction as, the first numerator as 2x times x plus 2. In the bottom of this, we have to find two numbers that multiply to negative 12 that add to negative 4, and that happens to be x plus 2 and x minus 6. All right, so this denominator factors to here. This numerator, when I factor out the greatest common monomial factors there. Now here, this is just a 2x on the bottom. Can't really do much with that. And now we need two numbers that multiply to 18 that add to negative 9. So that happens to be x minus 3 and x minus 6. And again, if you're not very good at factoring, you do want to review some of that factoring material back in chapter 4. All right. So along the top, we're just going to multiply all this together. 2x times x plus 2 times x minus 3 times x minus 6. On the bottom, x plus 2 times x minus 6 times 2x. All right. Now let's simplify. Both top and the bottom both have a 2x. Both top and bottom have an x minus 6. And both top and bottom have an x plus 2. And so you're left with one term, which is x minus 3. And that's all. All right? So we started fairly complicated there, but when you rewrite each of these in factored form, we can very easily see what's common in the tops and in the bottoms. All right? Why don't you guys try a couple of checkpoint problems again? Remember, factor first and then simplify. All right? Example number 1, we're going to rewrite this. The numerator factors into x minus 5 and x plus 3. The denominator of this factors into x plus 1 and x plus 3. You'll notice both the top and the bottom both have an x plus 3, and so we're left with x minus 5 over x plus 1. All right? In the second expression, both of these terms have a factor of 6x. So if I factor out 6x, that leaves x plus 3. In the denominator of this fraction, you will see that both of these, this x squared plus x minus 6 factors into x plus 3 and x minus 2. All right? The top of the second fraction, we need two numbers that multiply to negative 2 that add to negative 1. This happens to be x minus 2 and x plus 1. All right? And in the denominator of that, we need two numbers that multiply to negative 8 that add to negative 7. So that's x minus 8 and x plus 1. All right, now, we can go ahead and multiply all this together first, but man, I would sure like to simplify, because really by multiplying all of this, we're just extending this line all the way through. All right? So what do we have on the top and the bottom? We've got an x plus 3 on the top and bottom. We've got an x minus 2 on top and bottom, and we have an x plus 1 on top and bottom. So the only thing I'm left with on the top is 6x. The only thing I'm left with on the bottom is x minus 8. All right? Okay, so let's take a look at multiplying a rational expression by a polynomial. And this is the same idea. Really, anything, this polynomial function here is the same thing as this over 1. So this is x squared minus x plus 1. So I'm just going to do this. X squared minus x plus 1. All right? Now, theoretically, we should multiply all of this out, but I'm not going to waste time with that, because the top of this thing, this is all over 1. So on the bottom of this thing becomes x cubed plus 1 times 1, which doesn't really simplify, so this is just going to be x cubed plus 1. And on the top, instead of writing this as x minus 4 and going ahead and distributing or doing extended distributive property or whatever, I'm going to rewrite this in factored version. So this is now x and x. Two numbers that multiply to positive 1, and unfortunately that does not factor. Okay, that does not factor, so we can't factor this out. This is just x squared minus x plus 1. So on the bottom of this thing, then we have to say, all right, well, this does factor. All right, it might not look like it, but if you recall from chapter 5, I believe it was section 5.4 from your Algebra 2A, all right, we talked about the difference of cubes and the sum of cubes pattern. And the sum of cubes pattern, to review, a cubed plus b cubed is equal to a plus b times the product of a squared minus ab, whoops, got a little carried away with my parentheses there, plus b squared. All right, so that's the sum of cubes pattern. And I can see that what did I cube to get x cubed? Well, I cubed x. And what did I cube to get 1? I cubed 1. And so this is the sum of two cubes. And so this becomes x plus 1, x squared, minus 1x, or just minus x, and then plus 1 squared, which is 1. Now you'll notice the top and bottom both have an x squared minus x plus 1. And so I end up with x minus 4 over x plus 1. All right, and there's my answer. All right, so again, you have to recognize that denominator is the sum of cubes, and so otherwise that one doesn't factor, and you'd kind of be dead in the water. Okay? All right, let's talk about dividing rational expressions. Before we talk about dividing rational expressions, we want to remind ourselves that when you multiply fractions, if I was doing, for example, a over b divided by c over d, if I was dividing by fractions and these were just numbers, instead of dividing by a fraction, we can multiply by the reciprocal. So this would become times d over c. Well, the same thing applies here when we're dealing with rational expressions. If it's a over b divided by c over d, that becomes a over b times d over c. And then we're going to simplify if possible. All right? So we want to write this next division, this next quotient, as the product. So instead of dividing by this, we're going to multiply by its reciprocal, which puts the x squared plus 6x minus 7 on top, and it puts the 8x squared minus 8x on the bottom. Now in the numerator, we're going to go ahead and factor. We need two numbers that multiply to negative 7 that add to positive 6. So that's x plus 7 and x minus 1. And so that will be the factored version of x squared plus 6x minus 7. In the denominator of this guy, both of these have an 8x. So I'm going to factor that out, and that leaves me with an x minus 1. Now, before we start combining things, we're going to go ahead and take a look at the top and bottom and say, look, this has got an x plus 7, and so does this. This has got an x minus 1, and so does this. And I end up with just simply 3 over 8x. All right? Now, this lesson will spell disaster for you if you cannot remember how to factor. All right? So, let's try to take a look at the last two checkpoint problems. We'll be right back with solutions. All right, number 3, we're multiplying. So again, this is multiplying by this over 1. We'll notice again that the denominator of this thing is the difference of cubes pattern. If you recall, the difference of cubes pattern, a cubed minus b cubed, becomes a minus b times a squared plus ab plus b squared. All right, so in this case, my a is equal to x, and my b is equal to 3, because what did I cube to get x cubed? I cubed x. And what did I cube to get 27? I cubed 3. All right, so the denominator of this guy ends up being x minus 3 times x squared plus 3x plus 9. And the numerator of this guy, this is just simply negative 2x squared times x squared plus 3x plus 9. And conveniently, these two cancel, and I'm left with negative 2x squared over x minus 3. Now, I say that conveniently because, again, I want you to recognize that the book is choosing problems that they know something is going to cancel out. If nothing cancels out, chances are we made a mistake somewhere. Okay? All right, in the second example, then, we are going to divide by this mess here, but instead of dividing by that, we're going to multiply by the reciprocal. So this is x minus 5 over 9x squared minus 18x. We're going to multiply that by the reciprocal, which now puts this as 2x squared minus 5x plus 2, 2x squared minus 11x plus 5. Now, in the first fraction, this x minus 5 obviously doesn't factor. In the bottom, both of these have a common factor of 9x, and so that leaves me with an x minus 2. Where things are going to get very challenging here in this second fraction is now these are much more difficult to factor because they have a leading coefficient other than 1. So if you recall the snip method that we talked about way back when, we need to find two numbers that multiply to 4 that add to negative 5. And where we get 4 from is we multiply 2 times 2 because that allows us to take all the factors of the leading coefficient and our constant on the end. All right, so 2 times 2 is 4. We need two numbers that will then add to negative 5. And so to get positive 4, that's 1 and 4. They both have to be negative. All right, and then we write them both over our leading coefficient, which is 2x. And so our first factor becomes 2x minus 1. Our second factor becomes x minus 2 because both of these reduce by 2. All right. In the bottom of this guy, we now have, again, a times c, so 2 times 5 is 10, two numbers that multiply to 10 that add to negative 11. Well, again, this is negative 1 and negative 10, because to multiply to positive 10, they both have to have the same sign. And so there's negative 11. We're going to put them both over a leading coefficient, which again is 2x. And so our first factor is 2x minus 1. Our second factor, because these are both even, 2 goes into both of them, this becomes x minus 5. Now before I start putting things together, we'll notice this has got an x minus 5, and so does that. We'll notice these both have a 2x minus 1. And we notice that this has an x minus 2, and so does that. So everything on the top cancels out. We're left with simply 1. In the denominator, the only thing left is that 9x. And so 1 over 9x is your solution for number 4. And that concludes lesson 8.4. Again, the factoring is going to be the most difficult part of this. All right? Once you recognize how to factor, it should be pretty easy to recognize common factors.